Okay students, now we'll study about strain due to uniaxial stress. Now all of us know that in all engineering materials, the elongation produced by an axial tensile force in the direction of force is accompanied by a contraction in any transverse direction. So if you have a stress acting like this, as a result of a force in this direction, there will be elongation along the direction of applied force and contraction in all the other transverse direction. That is, if the material is homogeneous and isotropic, that is, their mechanical properties will be assumed independent of both position and direction. That is, the strain must have the same value for any transverse direction. Here this load is applied in this x direction. So in the y direction and in the z direction, in the y direction and also in the z direction, there is reduction in the dimension. That is, the strain have the same value for the transverse direction. So you can write epsilon Ey. So as a result, we can write that the strain in the y direction will be equal to the strain in the z direction. So what is Poisson's ratio? Poisson's ratio is lateral strain divided by linear strain. If Ex is the linear strain, the lateral strains will be same and that will be equal to mu into Ex. Okay. So since this is contraction, you can write here minus negative sign for contraction or decrease in dimension, negative sign for decrease in dimension and positive sign for increase in dimension. Okay. So you can say Ez will also be equal to mu equal to Ez by Ex. So you will get Ez equal to mu into Ex. This is also negative since there is decrease in dimension in the z direction also. Okay. Now we'll see what is the strain due to uniaxial stress. So in this figure you can see a stress sigma x is applied in the x direction. So as a result, let Ex be the strain in the x direction. We can write stress by strain is equal to Young's modulus of elasticity. So what is strain in x direction? Strain in x direction equal to stress in x direction by Young's modulus of elasticity. But we know Poisson's ratio equal to strain in the lateral direction by strain in the longitudinal direction. So we can write Ey is equal to mu into Ex. Since it is reduction in dimension, you can write minus mu into, what is Ex? Ex is sigma x by E. So sigma x divided by capital E. Now what is Ez? Ez also you can write here, Ez is equal to mu is Ez by Ex. So how can you write Ez? Ez is equal to mu into Ex. Here also there is reduction in dimension in the z direction. Let us take this as the z direction. So there is reduction in dimension in the z direction. This is the x direction and this is the y direction. Okay. So there is reduction in dimension in the y direction and also reduction in dimension in the z direction. So this is minus mu into sigma x by E. Okay, so you have got the strains in all the direction. So what is the volumetric strain for uniaxial stress? So since you have got the strain in all the directions x, y and z, now we can find out what is the volumetric strain. Now you have the equation volumetric strain is equal to EV is equal to Ex plus Ey plus Ez. Okay, here there is only stress in the x direction and that is the load is also acting in the x direction. So there is no load in the y direction. Py equal to 0, no load in the z direction. and hence there is no stress in the y direction and no stress in the z direction. So we can write the volumetric strain change in volume by original volume EV equal to Ex plus Ey plus Ez. But see, since here there is reduction in dimension in y direction and z direction, you can write here minus Ex minus Ey minus Ez. So what is this value Ex? Ex is sigma x by capital E minus mu into sigma x by capital E minus mu into sigma x by capital E. So you will get the equation sigma x by E into 1 minus 2 mu. Okay, so volumetric strain is sigma x by E into 1 minus 2 mu. So instead of sigma x, if P is the force in the x direction, you can substitute P by AE into 1 minus 2 mu. Okay. Okay, now we'll study about strain due to biaxial stress. So you consider a bar subjected to stresses in the x direction and also in the y direction. So what is the strain in the x direction due to the force sigma x? Let us represent it by the letter Ex1. It is equal to sigma x by capital E. Similarly, Ey1, you have the relationship mu is equal to Ey1 by Ex1. Therefore, Ey1 is equal to mu into Ex1, that is mu into sigma x by E. So, here Ey1 is equal to minus mu into sigma x by E because there is reduction in dimension. Similarly, Ez1 equal to minus mu into sigma x by E. How you have got it? Here you have mu is equal to Ez1 by Ex1. Therefore, Ez1 equal to mu into Ex1, which is equal to mu into sigma x by E. So, Ez1 equal to mu into sigma xe. Now, we can write what is strain in the x direction due to this stress y in the y direction. Ex2. What is Ey1? Ey2. Ey2 is equal to stress in the y direction divided by Young's modulus of elasticity. Due to this stress in the y direction, what is the strain in the x direction? You can write Ex2 by Ey2 is equal to mu. Therefore, you will get Ex2 is equal to mu into Ey2, that is mu into sigma y by E. Since this is negative, so there is reduction in dimension in the x direction due to stress in the y direction. So minus mu into sigma y by E. Similarly, Ez2 is equal to minus mu into sigma y by E. Okay. So what is this total strain in x direction? Ex equal to Ex1 plus Ex2, which is equal to Ex1 is sigma x by E minus mu into sigma y by E. Similarly, Ey is equal to Ey1 plus Ey2, which is equal to, what is Ey1? Ey1 is minus mu into sigma x by E. What is Ey2? Plus sigma y by E. Okay. Similarly, you can find out what is Ez. Total strain in Z direction is equal to Ez1 plus Ez2. What is Ez1? Minus mu into sigma x by E. And what is Ez2? Minus mu into sigma y by E. Okay. So now we can find out what is volumetric strain, change in volume by original volume represented by the letter EV, which is equal to EX plus EY plus EZ. So what is EX? Sigma X by E minus mu into sigma Y by E plus sigma Y by E minus mu into sigma X by E minus mu into sigma X by E minus mu into sigma Y by E. Okay. So we can write it as sigma X. We are taking outside. What are the sigma X coefficient values? This one and this one. Sigma X by E into, we can write it as sigma X by E into 1 minus 2 mu. Now taking sigma Y terms. Sigma Y and sigma Y plus sigma Y by E into 1 minus 2 mu. So how can you write this? Sigma X by E plus sigma Y by E into 1 minus 2 mu. That is a common factor. So if you are substituting instead of sigma X P by A, we can write 1 minus 2 mu by E into Px by area in the x direction plus Py by area in the y direction. Okay, this is the volumetric strain due to biaxial stress. Okay, now we'll study about strain due to triaxial stress, that is due to multiaxial loading, loading in all the three directions. This is known as generalized Hooke's law. So you consider a cubical parallel pipe. They subjected to stress in all the three directions, x direction, y direction and z direction. So you can write the strain in x direction Ex1 due to stress in x direction is sigma x by E. So due to this stress in x direction, there will be reduction in dimension in both y direction and z direction. So you can write the strain in y direction due to stress in x direction as minus mu into sigma x by E. Similarly, strain in z direction due to stress in x direction is minus mu into sigma x by E. So in the second case, so stress is applied in the y direction. So we can write the strain in y direction Ey2 equal to sigma y by E. So there will be reduction in dimension in all the other two directions, that is in x direction and z direction. So you can write Ex2 equal to minus mu into sigma y by E. This is the strain in x direction due to stress in y direction. Similarly, strain in z direction due to stress in y direction is minus mu into sigma y by E. Now you consider Ez, sigma Z applied in the z direction. So what is strain in z direction due to stress in the z direction? Ez3 equal to sigma Z by E. So as a result, there will be reduction in dimension in the directions x direction and y direction. So what is strain in x direction? Ex3 equal to minus mu into sigma Z by E and Ey3 equal to minus mu into sigma Z by E. So now we can find out what is the total strain in x direction, which is equal to x1 plus Ex2 plus Ex3. Substituting these values, you will get Ex1 is equal to Ex equal to sigma x by E minus mu into sigma y by E minus mu into sigma Z by E. In the same way, you will get Ey equal to Ey1 plus Ey2 plus Ey3. Substituting, you will get this value, and similarly Ez you will get all these values by substituting these values. So what is the total strain, volumetric strain? It is equal to X plus Ey plus Ez. So substituting all these values, summing up, you will get the volumetric strain is sigma x plus sigma y plus sigma Z into 1 minus 2 mu by E. Instead of sigma x, sigma y and sigma Z, you can substitute the load by area equation. So you will get the equation for volumetric strain delta V by V equal to 1 minus 2 mu by E into Px by X plus Py by Ay plus Pz by Az. So this is known as the generalized Hooke's law. See, here we have used the principle of superposition. That is, the effect of different forces is considered as a sum of the effect of individual forces. Okay, thank you very much.